Greetings, geometry students. I appreciate you finding time to get your notes taken care of. At this point, I believe this will be the second set of notes for the upcoming week, so these will be for Tuesday, December 9th, and the lesson is on congruent triangles. Please copy down the title, as well as your objectives. Our stated objective for today is the student will apply triangle congruence postulates to tell if pairs of triangles are congruent or not. It would be nice if everything was always congruent and the answers to our questions were always yeses, but that is certainly not the case. We will definitely see triangles that are not congruent to each other, as well as other polygons that are not congruent. So we need to understand what it is that we need to look for in order to decide that two triangles are congruent or not. On our assignment, the student will demonstrate the ability to examine provided triangles in order to determine whether they are congruent or if more information would be needed. Your essential question for today is, can I apply the triangle congruence shortcuts? Now, as the essential question suggests right there are shortcuts that can allow us to trim some of the work off of the list so that we can arrive at a conclusion that triangles are congruent or not based upon select pieces of information. As always, anytime you need more time to get notes copied down, don't let the video pass you by. Press pause and then hit play when you're ready to move forward. Let's get started. Okay, just like with many other topics in geometry, triangles are of special interest when it comes to studying congruent polygons. As the year unfolds, you will see that in plenty of situations where triangles hold more properties than a lot of other shapes, and it is those properties that we spend our time in geometry studying. The reason for this is because, like I said, triangles do carry certain properties with them that will allow us, in this case, to predict their congruence based upon only select pieces of information. Now, hopefully remember from our previous discussion on congruent polygons that in order to prove you have two polygons congruent, you have to prove that all sets of sides are congruent, all sets of corresponding sides are congruent, all sets of corresponding angles are congruent, and you had to prove all of that in order to say yes, they are congruent or no, they are not. With triangles, we only have to find a few particular pieces of information in order to answer the question. So the postulates we are going to look at today, and it should just say today, I've condensed it into one lesson, will greatly cut down on the amount of work that is required in order to say that two triangles are congruent or not. Fix this while I'm talking to you about it. There we go. So what we're going to need to do is we will have to take what information is provided for us and compare it to the postulates that we're getting ready to discuss to make a decision if one of the postulates can come to the rescue and tell us that we have congruent triangles or not. Now, one of the things you're going to have to remember is if you are not going to go through the full definition of congruent, in other words, if you're going to use one of the shortcuts, oops, sorry about that. If you're going to use one of the shortcuts, then you are going to have to state which shortcut you are using. So for those of you that are thinking yes or no questions, yay, it's a toss-up. I can just write down yes or I can just write down no, and those will be my answers. Well, those will be incorrect answers, because if you do say yes, they are going to be congruent, you got to state which shortcut allowed you to jump through and not answer all of the information in order to satisfy the main definition for congruent polygons. Okay, so let's take a look at the rules. There are 4 of them. The first one is called the side-side-side congruence postulate. Now remember, We have theorems in mathematics, which are big, long rules that have to be explained out in great detail. And then we have postulates, which are more common sense and do not require the big, long explanations. That's a definition we're still responsible for. And the side-side-side congruence postulate says this. If the three sides of one triangle are congruent to the three sides of another, then the triangles are congruent. Again, if the three sides of one triangle are congruent to the three sides of another, then the triangles are congruent. Now, if you pay attention to what was just said and compared it to what was said yesterday, you would notice that there is no information in this rule talking about any of the angle measurements from either of these triangles, and that's where this shortcut comes into play. With this postulate, it is not necessary to prove anything about the corresponding angles. Okay, so let's take a look at an example that might accompany a problem like this one. Now, the problems are not going to come out and tell you, here is a problem that you would want to think about the side-side-side congruence postulate. It will simply be a couple of triangles. It will be up to you to decide if you want to use a shortcut or try a shortcut like side-side-side. Now, obviously, if we are using a shortcut like side-side-side, we would want to be looking at two triangles that have pretty much all of our side information and possibly little, if any, information about the angles. And that's kind of what we're looking at here. If you saw an example where we had evidence of all kinds of congruent sides going on, but not really anything about any of the angles, this would be an opportunity to say, yes, they might be congruent by side-side-side. So let's take a look. For every side length in the triangle on the left, the red triangle, do we have a corresponding side length in the blue triangle on the right where we can prove that we have congruent sides? We've got one tick mark on the left, one tick mark on the right, two on the left, two on the right, three on the left, three on the right. It does appear that for every side that we have in the red triangle on the left, we do have a matching congruent side in the triangle on the right. So we would be able to say, in this case, triangle ABC is congruent to triangle DEF. And remember to get your vertices in the correct order when you name your polygons. And we need to state which shortcut allowed us to say that, because obviously we did not ever prove anything about any of the corresponding angles. So our shortcut that allowed us to say this is by side-side-side. Yes, you can abbreviate it just like I did right there, and that is your answer. If you were to simply say the triangles are congruent but did not identify which shortcut you used, then that would mean that you found all of the angle measurements as well, and clearly that is not the case, so that would be an incorrect answer. You have to put the shortcut as well. Okay, the next one, side angle side. Side angle side congruence postulate says, if two sides of one triangle are congruent to two sides of another, and the included angles, which means the angles between those sides, are also congruent, then the triangles are congruent. Okay, again, if two sides of one triangle are congruent to two sides of another, and the included angles, which means the angles that are caught between those two sides, the angles that are formed by the joining of those two sides, are also congruent, then your triangles are congruent. Okay, so obviously there is one set of sides that has not been mentioned by this postulate and two sets of angles that have not been mentioned by this postulate. So obviously we would be looking at, in this case, looking for triangles where we have a good bit of side information and some angle information, but possibly not all of the information to satisfy the definition without using one of the shortcuts. So with this postulate, it is not necessary to prove anything about the third set of sides or the other two sets of angles. Okay, so using the same two triangles that we used just a moment ago, but do copy these down again because there's different information marked this time. Okay, and as you can see, again, these problems are not going to come out and say use side, angle, side. It'll be up to you to determine that we do have a couple of sets of sides that we can discuss and a set of angles that we can discuss. So side, angle, side is an option if it fits the definition. Now the rule said two sides of one triangle congruent to two sides of another. And yes, we do have that. We can tell by the matching tick marks. We got a set of one tick marks and a set of two tick marks. Okay, so we do have two sides that are congruent. And then it says the included angles must also be congruent. So you can see where the sides that have the one tick mark and the two tick marks join together, there is an angle in there that we do have information about. In the triangle on the left, that would be the angle near vertex B. In the triangle on the right, the vertex near angle near vertex E. And it is marked as being congruent. So we do have a set of sides congruent, and then a set of angles congruent, and then a set of sides congruent, exactly like the order of the name suggests: side, angle, side. So we would be able to establish, yes, once again, triangle ABC is congruent to triangle DEF. If you just put that, you just missed the question because you have no way of proving the other set of sides or the other two sets of angles. So you must identify the shortcut, and in this case, the shortcut was side, angle, side. And yes, you may abbreviate it just like that, and that is your answer. Okay. Third of the four rules is angle, side, angle. Now this one works exactly the same way that side, angle, side just worked, but of course you can see the names are reversed. So the wording is almost identical, just a couple of vocabulary words switched. If two angles of one triangle are congruent to two angles of another, and the included sides are also congruent, then your triangles are congruent. Again, if two angles of one triangle are congruent to two angles of another, and the included sides are also congruent, then the triangles are congruent. Okay, so obviously we would be considering using angle, side, angle if we had the majority of the angle information and at least some of the side information, but might be missing the third set of angles or the other two sets of sides. With this postulate, it is not necessary to prove anything about the other sets of angles or the remaining sides. Okay, so looking at two triangles again, same two triangles, but yet again different information marked this time. Okay, we would be thinking about a rule like side, angle, side in this example, because as we can see, we do have a couple of sets of angles that we can look at. We can see that we do know that they are in fact congruent from one figure to the next. And in between the two sets of angles that we do know, we have an adjoining side, the included side, that is also marked as being congruent in both cases. Okay, so that would enable us to say, yes, triangle ABC is congruent to triangle DEF. Okay, if that's all that you put, you're going to miss the question because you have to identify the shortcut that you're using because we do not have the other set of angles or the other two sets of sides. Okay, but we have a set of angles that is congruent, then we have a set of sides that is congruent, and then we have another set of angles that is congruent. So in that order, as the name suggests, angle, side, angle. Okay, so you can abbreviate it, ASA, and that is your answer. Okay, final rule, angle, angle, side. Now, angle, angle, side, as you can tell, uses the same information that the previous rule did, two sets of angles and one set of sides, but the order is changed. On the previous one, we had a set of angles, then a set of sides, then a set of angles. So the set of sides was positioned between the two angles that were in question. In this case, we have a set of angles, and then a set of angles, and then a set of sides. So the rule reads, if two angles of one triangle are congruent to two angles of another, and a non-included side is congruent to its corresponding side, then the triangles are congruent. Okay, non-included simply means it's not in between. So the one set of sides that we do know is not going to be positioned between the two sets of angles that we do know. Okay, so with this postulate, obviously, it is still not necessary to prove anything about the other set of angles or the remaining sets of sides. Okay. So once again, let's look at the two triangles, triangle ABC and triangle DEF. And again, we have different information marked. Okay. If the definition fits, we will use it. Okay, so in this problem, we might suspect a rule like angle, angle, side, or maybe angle, side, angle, because again, we do have a couple of sets of angles and we have one set of sides. But we don't want to get confused with the previous postulate that we just went over, ASA. Okay, we would need to make sure that we get the sides positioned correctly, because not only if you don't identify the shortcut that you use, okay, it will be counted incorrect, but if you identify the incorrect shortcut, then obviously that can kind of cause it to be incorrect as well. So clearly, from one figure to the next, the red one to the blue one, we do have two sets of corresponding angles that are congruent. We have one set of corresponding sides that are congruent, and the positioning is going to be important. Is that set of sides in between the two angles that we do know, or is it not between the two angles that we do know? Well, in this case, it's not. Okay, so we do have a rule that goes with it, and that rule would be angle, angle, side. So we would be able to say the triangle ABC is congruent to triangle DEF, and we would have to identify that we would use angle, angle, side, and that would be our correct answer. If you put angle, side, angle on this one, then you just said you were able to find the set of sides that is between the two angles, and clearly that is not possible in this one, so that would cause you to miss it. You got to use the correct shortcut in order to skip over having to use all of the work that the congruent definition showed us last time. Okay, next thing we're going to do is we're going to look at a big old pile of triangles here, and we're going to see if we can identify which sets of triangles are using which of the rules, or perhaps which sets of triangles might not have enough information for us to use any of the rules. Okay, so copy down this question. I'm going to give you several diagrams, and I'd like you to take a shot at the different problems that I'm giving you here. See if you can figure out which of the rules would apply, if any of the rules do apply. Can we tell if the following triangles are congruent? If so, how? Okay, so it's not just yes or no, this is explanation stuff. Okay, so there are on the screen there 7 different sets of triangles that might be congruent or not. I want you to take a moment, press pause, and copy down all of the different sets of triangles, including the information that is provided, obviously, parallel markers, tick marks, right angles, all that good stuff. And I want you to consider the information that is actually marked in the pictures, and also consider other definitions that we might know about that we've covered this year that could help us with extra information in the picture. Rules like the reflexive property, where something is equal to itself, or vertical angles, which are across from each other at an intersection that could be considered to be congruent. Parallel lines and transversals. We get rules like same side interior angles, alternate interior angles, things like that that can tell us about the measurements of different sets of angles. Okay, so here in a moment, go ahead and press pause if you need extra time to copy these diagrams down. Once you get them copied down, press play in order to finish the video. Okay, the only thing remaining for you to do is to respond to those 7 sets of triangles, consider the 4 different definitions, and see if you can find any of the congruence rules that do apply. If you cannot find one, well, then put that it's not congruent or that more information is needed, and then we'll look at them when we get in class on Tuesday. Jot down a summary of your information, notate any questions that you have about the material, and always keep your essential question in mind. Can I apply the congruent triangle congruence shortcuts? I appreciate you getting your notes taken care of. I'll see you in class.